Hi everyone, this is the second video on how to derive the trigonometric ratios of compound angles. I have already created a video on how to derive sine of a plus b and cosine of a plus b. In this video, we are going to discuss about how to derive sine of a minus b and cosine of a minus b. We will do both of them geometrically as well as trigonometrically. So in the diagram, as you can see, let's assume that we have an angle A which is denoted by the green color arc, the larger angle, that is A, and then the smaller angle which is up there, the upper angle, the smaller one, that is B. Then the lower pink colored angle, that would be a minus b, because the large one is A and the upper smaller one is B, so the lower smaller one will be a minus b, the difference of A and B. And we have to find out trigonometric ratios of this angle which is a minus b. So let's do some construction here. First of all, because we have to find the trigonometric ratio of a minus b, we have to somehow create a right triangle. So let's pick a point P on the OY ray. So I'm going to pick a point P right here. Let's suppose this is our point P, and then from P I'm going to drop a perpendicular onto OX, and let's call it PQ. Now let's also drop another perpendicular onto OG. So from P we are going to draw a perpendicular onto OG, and let's call it PR. So this point right here on OG, let's call it R. That is the point R. So PR is a perpendicular on OG, so let's denote that. And similarly PQ is a perpendicular on OX. Now we are also going to draw a perpendicular from R onto OX, and let's call it RS. And then from R we are going to draw a line segment which would be parallel to the OX ray. So from R we are going to draw a line segment kind of like this. Let me do the yellow dotted line here, and then we are going to extend QP to meet this dotted yellow line, and let's suppose they meet at point T. And now if you think about the quadrilateral which is RSQT, here you see that RS is parallel to TQ, and similarly RT is parallel to SQ, and also we have an angle, say RSQ, that angle is a right angle, or similarly TQS is also a right angle. So now we have a parallelogram where the opposite sides are parallel and one angle is a right angle. In fact, we can clearly see there are like two angles which are right angles. So we just need one angle to be right angle for a parallelogram to become a rectangle. So essentially RSQT is nothing but a rectangle. That means the angle PTR, that is also a right angle. And now if you think about the angle ZRT, that angle will be equal to angle A. Why? Because RT is parallel to OX, and if you assume or if you consider OZ to be the transversal, then obviously ZRT angle will be equal to GOS or GOX. So that means this angle right here, ZRT, that angle is nothing but A. That is actually equal to A. Now can we say that angle ZRT, which is A of course, plus angle PRT, so let me write it down here. So angle A meaning angle ZRT, so let me write it down here, angle ZRT, which is obviously equal to A, plus PRT, angle PRT, that is equal to 90 degree, because PR is a perpendicular onto OZ, so that will be equal to 90 degree. And similarly, if you look at the little triangle there which is PTR or PRT triangle, that is a right triangle. So there again angle PRT plus angle RPT is also equal to 90 degree. And now from here you can clearly see that GRT will be equal to RPT, because these two are equal. It's the same angle right here, PRT and PRT here again 90 degree, 90 degree. So from these two equations we can clearly prove that angle ZRT will be equal to angle RPT. So from here we can say, well, then angle RPT is definitely equal to angle ZRT, and which is equal to A. So now we can see that angle RPT is essentially equal to A. So I'm again denoting that right here with a green arc and A. So angle RPT is also equal to A. So by now our construction is complete. Now let's get into the derivation. So what would be sine of A minus B? Well, can we write sine of A minus B like this? That will be equal to PQ over OP. And can we write PQ as TQ minus TP? And from here can we say, well, TQ is essentially equal to RS. So can we write RS in place of TQ? And that can be written as RS over OP minus TP over OP. And from here again we're going to do a trick. The trick is kind of like this. So here we can say, well, can we write it like this? Can we say, well, this can be written as RS over something, I'm going to fill in the blank little later. So Rs over something times the same equal thing over OP minus again TP over something times the same something over OP. And now you see how we fill in the blank here. Now we have to find a common side which will be in trigonometric relationship with Rs as well as OP. So can we find a side like this? Well, if you think about it, OR would be a common side for Rs and OP. So let's go with OR. So here I'm going to put OR right here and similarly OR right here. And also we have to find another common side which will be in trigonometric relation with TP and OP. Can that be RP? Yes, because RP and TP, they have a trigonometric relationship, and RP and OP, they also have a trigonometric relationship. So let's use RP over there. And now we are almost done. So from here we can say, well, this is looking like Rs over OR, that would be sine of A, times OR over OP, that will be cosine of B, and then TP over RP, that will be cosine of A, times RP over OP, that will be sine of B. So essentially we have found the value of sine of A minus B. So let me quickly write down right here. So sine of A minus B is equal to sine A times cosine B minus cosine A times sine B. I hope everything made sense so far. Next we are going to derive the value of cosine of A minus B. That will be equal to OQ over OP, the ratio of OQ over OP. And then can we write OQ as the sum of OS and SQ? And now we can see that SQ is equal to RT. So I'm going to use RT in place of SQ. So we can say, well, this can be written as OS plus RT over OP. And now we are going to separate them. So you can write it as OS over OP plus RT over OP, and then we're going to write it like this. We're going to say, okay, let's do OS over something times that something over OP, that is the first term, plus then RT over something times something over OP. And here again we have to find a common side which would be in trigonometric relationship with OS as well as OP. So let's try to find a side like that. And as you can see in the diagram, OR would be a good candidate for that, because OR and OS, they have a trigonometric relationship, and similarly OR and OP, they also have a trigonometric relationship. So let's use OR for the first term. So I'm going to write it like this. And for the second term we have to find another common side that will be in trigonometric relationship with RT as well as OP. And from the diagram I can clearly see that RP would be a good candidate, because RP and RT, they have a trigonometric relationship. Similarly OP and RP, they also have a trigonometric relationship. So let's use RP then, and let's try to find out the ratios here. So OS over OR, that is going to be cosine of A, and then OR over OP, that will be cosine of B, plus RT over RP, that would be sine of A, times RP over OP, that would be sine of B. Alright, so we have found the value. So let me make a quick note right here. So we can say cosine of A minus B is essentially equal to cosine of A times cosine of B plus sine of A times sine of B. So this was the geometric way of deriving the value of sine of A minus B and cosine of A minus B. Now there is a trigonometric way of doing it also. So let's quickly discuss that. In the previous video we have derived that sine of A plus B is equal to sine of A times cosine of B plus cosine of A times sine of B. So now what would be sine of A minus B? Well, sine of A minus B, let me first make a quick note here. Sine of A minus B can be written as sine of A plus negative B. Think about it. And now in that case, can we write it as, well, then wherever we have B, I'm going to use a negative B. So you can say this will be equal to sine of A and then cosine of negative B plus cosine of A times sine of negative B. And now if we simplify this, it would be sine of A times cosine of negative B. Cosine of any negative angle is same as cosine of the positive angle. So this will be positive cosine of B, because the sign of cosine in the fourth quadrant is positive. So we can say cosine of negative B will be a positive cosine of B. And then for the second part, we have cosine of A times sine of negative B. Well, in the fourth quadrant, sine is actually negative. So it will be negative sine of B. So here I am using the negative sign then, and sine of B. And this way also we could derive the value of sine of A minus B, which turns out to be sine of A times cosine of B minus cosine of A times sine of B. Now let's do the derivation of cosine of A minus B in a similar way. From the previous video, we have seen that cosine of A plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. And now what would be cosine of a minus b? Well, cosine of a minus b can be written as cosine of a plus negative b. And now using the same formula which I have written just in the previous line, so we can say, well, then this can be written as cosine of a times cosine of negative b minus sine of a times sine of negative b. And then from here we can write it as cosine of a times cosine of negative b is equal to positive cosine of b, so no change in sign here. And then on the second part we have sine of a times sine of negative b. Well, sine of negative b is actually negative sine of b, so sine of negative b gives us a negative 1 and we already have a negative sign there, so this will become positive then. So now I am filling up the blank there, so now we understand that yes, it will be a positive sign there, so it would be positive sine of a times sine of b, and this is the value of cosine of a minus b. So we have been able to derive the values of sine of a minus b and cosine of a minus b using trigonometry, and also we have seen the geometric derivation. So this brings us to the end of this video. I hope everything made sense. Thank you for watching. See you in the next video.